So yeet cannons are finally a reality. Spinlaunch just launched their brand publicly, and they also launched their actual first test flight, and they filmed it, and it was awesome. Now, Spinlaunch is essentially launching payloads to orbit without a first stage rocket. So what is Spinlaunch, and are they going to replace rockets? Let's see.
Now is the time to take risk.
Okay, so first off, Spinlaunch was founded in 2014 by Jonathan Yanni. Before Spinlaunch, Jonathan was working on a startup that was building solar-powered drones called Titan Aerospace. He eventually sold this to Google, and then he started working on this. So after 2014 and spending like 4 years on it, they made headlines in 2018 by saying that they wanted to raise $30 million for their Series A to build this. And I've been following them since then, and they've been pretty quiet, but finally we're getting some good news. They raised money from VC firms like GV, Kleiner Perkins, and fittingly Airbus Ventures and Catapult Ventures. I just love that those names are investing in this, and others. Anyways, so they arrived out of stealth earlier this week with this awesome demonstration. So in this video, we're shown their massive 33-meter diameter suborbital accelerator accelerating a rocket that was 3 meters long, shooting it out of the tube, ripping the cover, and launching it at supersonic speeds. Now, this is pretty incredible tech, and there's a lot of engineering here, so let's dive in. This is an alternative launch system. The idea isn't new, but most of these ideas haven't really taken off yet because it requires more engineering, mostly. That's kind of the reason. But basically, their plan is to spin this rocket really fast and then launch it out of the tube, and then an engine will bring it to orbit after that. Now, their current prototype of this alternative launch system uses a massive 33 diameter system. And if you take the height of the system with the tube, it's taller than the Statue of Liberty. And this is a vacuum chamber. And this is the largest vacuum chamber in the world. And this is their prototype. So that's pretty crazy. Now, this test launch was running at only 20% of their maximum power, supposedly. And according to calculations by Scott Manley, it was rotating around 180 RPMs or rotations per minute to move the payload beyond Mach 1. And he also thinks that it went around 10,000 feet high, or 0.3 kilometers, which honestly isn't getting super close to space, but you know, it's a test flight. Okay, as for the full-scale model, this one's 33 meters in diameter. Their full-scale one is going to be 100 meters in diameter. So 3 times larger than this, with a max 450 RPM rotation launch speed, which is 2.5 times faster rotation than this prototype. And they're planning to be able to deliver payloads for customers to space by 2025. So one of the main questions that comes up is like, what about the G-forces? Well, it turns out that standard hardware can surprisingly withstand these G-forces, and that's because the pressure is distributed among the entire piece of hardware instead of just at one single point. So it doesn't fail. Spinlaunch actually has a 12-meter diameter testing environment that they built specifically for this, and they can spin objects up to 20,000 Gs, which is double the G-force that the payload should be enduring when they're in the 33-meter and the 100-meter launch systems. So they're doing a lot of testing, and they're finding that, you know, most hardware is actually surprisingly okay. And there's also precedence with this with the military. The military's done a ton of research into high G just because they're launching missiles from, you know, 0 to Mach 1 in like 5 seconds or so. I don't know the exact time, but like they can accelerate immediately. Check out this video, and like clearly some hardware can withstand that. But obviously this limits their customers to certain types of payloads, and this is a disadvantage. So what are the advantages of this system? The big two are cost and fuel. So supposedly they are saying that it will cost 10 to 20 times less than smaller launch systems. So what they're referring to there is rockets like Rocket Lab, and Rocket Lab currently has a price of $25,000 per kilogram to orbit. Now, there are even smaller rockets that are claiming like $9,000 per kilogram. For reference though, SpaceX is around $2,000 per kilogram to orbit, not including Starship, but they are a bigger rocket. So let's assume Spinlaunch is using like a $10,000 per kilogram for their smaller launch systems to compare against their price. This means that if Spinlaunch can hit a 10x cost reduction, they would be able to launch for $1,000 per kilogram to orbit, which is less than the current Falcon 9, which is crazy. And obviously this will be available in 2025, so like prices from Rocket Lab and other launch systems and SpaceX should all fall. That's crazy. This might be like the cheapest claim on the market. I'm not exactly sure, other than like Starship. Let me know in the comments if there are other startups claiming cheaper launch prices though, but $1,000 per kilogram is nuts. And this price is pretty nicely following the decline of traditional launch prices. So obviously the main benefit of reducing the cost is that you can launch satellites more cheaply because you don't have to engineer them to be like 0.99999 safety tolerant. They can just be 0.99 safety tolerant or something like that. And like if it fails, then it fails and you just send up a new one and it's a lot cheaper. So this should drastically reduce the price of satellites. And then if you do that, you can get more satellites up to space in the first place. So it will be easier to build full constellation projects and for startups that are doing these satellites to get off the ground. Also, they say they're planning to be able to do multiple launches per day, which a lot of space startups claim, but that'd be pretty nuts. But the second benefit of this system is fuel. So aside from cost, there is a reduction in fuel, and they still require a rocket engine stage after launching, but they are still claiming that because they spin it, they launch it, doesn't require fuel at that point, it's a 4x reduction in fuel. Now, a lot of people will be like, okay, that's good because then it reduces pollution from rockets, and like, yeah, that's good. But at the same time, rockets are such a minor pollution compared to cars, and like some rockets even produce hydrogen after combustion. So this isn't like the main benefit here. The main benefit is that with less fuel required is that you can increase your payload. And so they're claiming that they can actually deliver 200 kilograms to orbit. And this is pretty big because Rocket Lab, who has a full-scale rocket, is saying that they can only deliver 300 kilograms to orbit. So like this is comparable to Rocket Lab. Of course, this doesn't take into account 5 years down the road, Rocket Lab might be getting like 500 kilograms to orbit and Spinlaunch is still 250, but still, that's pretty close. Also, I'm not sure where Spinlaunch is like delivering their satellites. Like, is it low Earth orbit, GEO? Like, how far can they get? So that, these numbers are rough. But what they're saying is that they can launch the same type of payload as Rocket Lab for 10x the price. That's crazy. So like if a startup is building equipment that can actually survive the G-forces here, why would anybody choose Rocket Lab, right? So hold on to your Rocket Lab stock? I don't know, but at least Rocket Lab's launching, but whatever. Okay, and the third benefit is that they can launch multiple times per day. And I'm guessing this is because the rockets are more easy to manufacture, less complex than Rocket Lab, but they also do have to manufacture a rocket that will survive G-forces, so who knows how long that'll take, but that's the third benefit. They can just like keep spinning the system and get the rockets out there. Okay, so the fun part of this video is what does the future of Spinlaunch look like? Like, why am I talking about this? Why is this cool? Obviously, they still have some things to do, like building their rocket that can survive these G-forces and deliver payloads to orbit, and they still need to build the bigger 100-meter diameter vacuum chamber, which is going to be triple the largest vacuum chamber since theirs is currently the largest, and still be able to launch a rocket with millimeter precision at 450 RPMs through the launch tube and balancing the rotational forces in the chamber. They have a long road ahead of them, but assuming that they can do that, and this part is kind of the speculation part, what would make me bullish on this startup? So before I talk about what makes me bullish, I need to explain one of the biggest problems with Spinlaunch is that as they launch their rocket at supersonic speeds out of that tarp, they're encountering extremely dense air near sea level or wherever they are, like a typical rocket that's just like starting to go up, and then as it gets faster, the air gets less dense. Now, obviously we have materials, like I said, that can survive in the atmosphere at these supersonic speeds, like this, whatever material this military missile is made from. But even though Spinlaunch has proven that they're able to overcome this super dense atmosphere, I don't think this is where they're gonna shine. Now you can see where I'm going with this. Spinlaunch doesn't require as much fuel, and it's advantageous to launch Spinlaunch in a vacuum ecosystem. And so what that means is that on the moon and Mars, on the moon where it's nearly a vacuum and Mars where it's 100 times less dense than Earth's atmosphere, they have a huge advantage here. They have a competitive advantage among their peers. So essentially, I think Spinlaunch will thrive where fuel is hard to create. So this is the moon and Mars to start. And don't get me wrong, we'll still be able to produce fuel on the moon and Mars. Like, I think this is a super important technology stack. We're going to figure it out. And we'll need fuel either way because Spinlaunch will still need fuel for their engine after it gets launched and it needs to turn on. And two, for launching people and G-sensitive objects, you still need fuel. You can't use this Spinlaunch apparatus. But it will cost significantly less energy to create a vacuum on the moon or Mars. So honestly, I could see them building even bigger rockets that can hold decent payloads, and either launching the payloads from the moon to a starship that's orbiting the moon. That way the starship doesn't even have to land on the moon. Spinlaunch can just send them a payload and then Starship goes to Mars or something and delivers stuff like it's a ferry. Or maybe they want to develop like propulsive landing themselves, so they just Spinlaunch, shoot out, head to Mars, and then go land on Mars. I don't know if they'll do that, and aside from sending payloads to an orbiting starship or to another planet, there's obviously like they're built to launch satellites. So then if you have a spin launch on a planet or a moon, and then you can just like launch satellites instead of having to wait for Earth and launch satellites from Earth, you just launch them from the moon or Mars, and then you have a constellation built up from materials on the moon. I think that's pretty sick. Now, obviously, I don't know how the economics of this will work. This is pure speculation. But if one of these can launch multiple payloads, let's say that their technology progresses where they can launch like 5 payloads per day of 1 ton each, because gravity is a lot less on the moon and Mars, and they build even just 5 of these, that's 25 tons per day that can be launched into orbit, either satellites or payloads to Starship or heading to another surface. Obviously, the numbers change depending on the mission profile. But like, that would save Starship a ton of fuel from having to propulsively land on the moon and then go back up and go to Mars or something. And like, Starship's payload is between 150 tons when it wants to be reusable and 250 tons to orbit from Earth, seems to be its max right now. So like, if we had 5 of these per day launching 5 tons each, then that's 25 tons. So in 10 days, we could fill up a full Starship and it can just head off to Mars. That's crazy. I think that's cool. Obviously, that's just materials and you're not going to send up people like that. I think this could be big for saving Starship a lot of time and energy on propulsively landing on other planets when it could just orbit and act as like a cargo shuttle. So that said, I'm still very confident that we're going to get really good at creating fuel from the surfaces of these planets. Like, I was just reading this paper about using algae to make rocket fuel, which I think I'm going to make a full video about soon. So Sasa, subscribe if you want to get notified when I post that. But yeah, every bit of mass to orbit helps, and Spinlaunch is pretty perfectly positioned to become a Moon and Mars surface to orbit launch system, much more so than I think it is on Earth. But you know, even if they can get it cheaper on Earth, that's still a win. So yeah, those are my thoughts on the Yeet cannons. It's finally becoming a reality, which is just like sick in general. And you know, I like this startup. I think it's cool. Would I invest? I don't know. I don't think, you know, the economics might not be there, but I still think it's sick. Thanks for watching. And I'm trying to post, you know, a video each day. During the week, a YouTube video, and then during the weekend, my YouTube shorts. And if there are any ideas or hard tech startups that you want me to cover, sauce a comment. Sauce a comment if you're feeling generous. I'm trying to get monetized out here. Gotta give me engagement, guys. And yeah, but otherwise, I'll see you guys in the next one. Peace.